All right, welcome back, everybody. We're going to go over number 12 here in the homework. Okay. Oh, I erased my cheat. I threw in my cheat sheet over there. Oh, well, that's okay. Do I need it for secant squared? I think I do. Yeah. Shh, quiet, folks. Okay, so here we go. We got secant squared 2 theta. Secant squared 2 theta. So remember what this means, that if you've ever had like a trig squared, all they're doing there is just taking secant of 2 theta squared, right? That's equivalent right there, okay? So I've had a lot of people like, okay, so is the 2 theta squared? Is the what? No, they're just saying the secant 2 theta squared. The only reason we use this notation where the square jumps inside there is to make sure the reader knows that the 2 theta is not squared, just the secant, the full secant 2 theta squared. Okay? Now, for our purposes here, we're going to treat the u as 2 theta. Okay, so that means du is 2 d theta. And be careful here, I don't see the 2 anymore. The 2 is gone from my original, because what's going to happen here is I'm going to take the original, I'm going to take it as the integral of secant squared of u, right? And I've got to put a du in there, right? So what is it? But what is equivalent to d theta? 1/2 du. Okay. So this has got to be secant squared du times 1/2 du, which I can rewrite to say the integral of 1/2 secant squared u du. And now we just have to know what secant squared. Yeah, question.
Is it fine if we put that 1/2 on the outside?
Yep, actually the book uses that notation. The book brings all constants out front. I don't know. I like to leave them in. You can bring them out front. Doesn't really matter. All right, so we got 1/2 secant squared u du. Let's do the integral of secant squared. So the integral of secant squared looks like it's tangent u. That's it? That's all it is? Oh, that's nice. So the integral of secant squared is just tangent u. All right, so it's 1/2 tangent u plus c. And then we plug u back in. So u is 2 theta. So it's 1/2 tangent 2 theta plus c. And that's my final answer. 1/2 tangent 2 theta plus c. Question. What else do we want to talk through? Go ahead. 24?
Yeah.
24. Oh, this is that weird one with the x and the x plus 2. This is a funky one. I'm glad we asked about this one. This is going to be a fun one. Did it come up? Oh, it's already over there. Okay. So we've got x square root of x plus 2 dx. So does it tell you what the u is here? No. What do you think it's going to be? X plus 2. That's my first instinct as well. So let's make the u x plus 2. That means that du is, well, if I take the derivative of this x plus 2, what's it going to be? Just 1, right? So it's 1 dx, or just dx. So du is dx. All right. So essentially what I'm doing here is I'm changing this, and I take the square root of u, and then du. But there's still an x sitting out front, right? I didn't replace, the only thing that replaced dx was du. And the x plus 2 went in for just a u. I haven't touched my x yet. So what is equivalent to x in terms of u? u minus 2 is x. Okay? We can use the fact that since u is equal to x plus 2, u minus 2 is x. And then we can plug that in. We could say that that's going to be equivalent to u minus 2 square root u du. Because that's equivalent to x, u minus 2 is x. Which means that I can take, I'll do a little intermediate step here. That's u minus 2 times u to the 1/2 power du. And now let's distribute in. So u to the first times u to the 1/2. Same base, add exponents. U to the 1 plus 1/2 is 1.5 or 3/2. U to the 3/2 minus 2 u to the 1/2 du. And all I did was add the exponents because I was multiplying the bases. And now at this point, I perform the integral. So I say u to the, okay, raise it up 1, which is 2 over 2, so 5 over 2, u to the 5/2, right, because it would have been 1.5, pick it up 1, 2.5, which is 5 over 2, divided by 5/2, minus 2 u to the 3 over 2, because it would be 1.5, so 3 over 2, divided by 3 over 2, and plus c. Let's manipulate the fractions a little bit. Right? Dividing by a fraction is multiplying by the reciprocal, so that's 2/5 u to the 5/2 minus, and now I would take 2 divided by 3/2 or 2 times 2/3, right? 2 times 2/3, so it'd be 4/3. 4/3 minus 4/3 u to the 3/2. Plus c. And now we take out u and plug back in x plus 2. So that's equivalent to 2/5 x plus 2 to the 5/2 minus 4/3 x plus 2 to the 3/2 plus c. Yes?
Are you recording?
I thought it did. Did I not?
No, you are.
Oh, I am. Okay, good. I didn't want to go through that problem again.
Just wanted to.
Appreciate it. That was a weird one. Why was it weird? Because of this right here. That was the weird piece of this. Because there was still something that we had not seen. When you do u substitution, no pun intended there, when you perform u substitution, you have to turn all of the, you got to get all of the x values cleared out of the integral, make them all u, then perform the integral. So all of the x values must go away from the original problem. They had not yet when I had done my original u substitution. I had this x still sitting there. So we had to get that x to go away. Usually we can find x in terms of u, because that's generally how we start with the whole process. Create an equation for u. Okay, what else do we want to do? Keep it rolling. Go ahead, man. 18. 18, 18, 18. Ooh, this looks like a fun one. Oh, did I get the square root in there? I did. Okay, good. All right. What do you think u should be? What do you think u should be? X to the 1/2 the square root of x? Yeah, I like that. Let's make u the square root of x. Let's take u as the square root of x. Why do I pick that? Well, because think about it. Look at the top. I've got sine of the square root of x. So if I've got the square root of x within sine, then that's probably going to be my u. Remember, you're always looking for a function within a function. Something within something else, like a chain rule type thing. All right, so let's do the derivative. Du well, you know what? You're right, I should have made it just x to the 1/2 power. Because now when I go to find the derivative, du, bring it down front, kick it down, right? 1/2 x to the negative 1/2 dx. Okay. I don't see any whole numbers. I'm gonna boot that 1/2 over to the other side, make it a 2 du. And then watch what I'm gonna do here. I'm gonna make it 1 over the square root of x. Why do I do that? Because I see it within my original. Couldn't I rewrite my original? You don't have to do this step, but just to kind of show you, isn't this really just 1 over the square root of x times sine square root of x dx? And now do you see in there the 1 over radical x dx? And that's equivalent to 2 du. So this means that I've got the integral of, remove all the x's, sine u times 2 du. That makes sense? Yeah.
So you don't have to, like, with your U and DU, you don't have to try and figure out the sign and things and take it out.
Well, I'm going to do that now.
You don't have to get it.
Right. Because all I'm doing is just manipulating what the integral looks like. Now, once I perform the integral, now I have to figure out what the integral is like. See, before this was all just manipulation of the integral. Now I actually perform the integral. So what is the integral of sine again?
Cosine.
Thanks.
Negative, yeah.
Is it negative or positive?
Negative.
It's negative, right?
As testing everybody.
Just test. So it's negative. You know what? I like to write out the whole number in front. Okay. So that's going to be negative 2 cosine u plus c. And now we take out u and plug in x. So negative 2 cosine the square root of x plus c. And there's my answer. That's it. That's everything. There it is. What was that? Did you need something? You probably did. Yes, you did. There you go. As soon as I got paid. No, you're fine. You're fine. He's like a nicer pro. I'm so sorry for interrupting your question. Oh gosh, I still have my hat on. I was wondering, John was looking at me halfway through the class. All right, what other questions do we want to go through? Go ahead, go for it. Number 7? 57. 57. There it is.
Oh, God.
Oh, she could not. Yeah, the end is a little, that's okay. You guys got this. You're smart people. You guys are smart people.
Don't appreciate the confidence.
Okay, so we've got sine t over cosine squared t dt. Let's, the way I like to do these problems is I like to try to create my u, see what's going on with my u, see if what I picked as a u works, and then, because I don't want to do the whole thing of trying to find u and then it doesn't work and then I've created the endpoints wrong too. So I'd rather just leave the endpoints behind and then pick them back up at a later date. Okay, so we've got to figure out what my u needs to be. I'm going to cheat and look what I used. Looks like I used cosine. cosine. Cosine t.
I know too. Oh, because it's cosine.
Yeah.
Got it.
Because technically, think about it this way. Isn't this really cosine t? No, cosine t squared. So it has that look of function within a function, right? So that's why I'm picking my cosine. All right, so du, what's the derivative of cosine? Negative sign, right?
No.
It's just,
It's just
No, when it.
That's the.
Yeah, we're talking about derivative stuff.
Derivative, not the antiderivative.
Yeah, see, and that's the weird part here, especially with these trig functions. You got to flip back and forth between taking antiderivatives and derivatives.
So,
Remember, the derivative of sine is cosine. The derivative of cosine is negative sine.
so why was it the antiderivative of sine that was negative cosine? Oh.
Right. Yeah, and that's where it starts to get a little, a little confusing, a little messy. Oh, okay, so we got du is equal to negative sine t dt, which is good because don't I see a sign up there? I saw the sign. So we got negative du is equal to sine t dt. So that means that I can take, and think about it this way. This is really equivalent to 1 over cosine t squared times sine t dt, right? I just kind of removed it and put that squared above. Why am I doing that? So that you guys can truly see how these are going to substitute in. So that means this is a 1 over u squared, right? 1 over u squared, because u is cosine, times, now sine t dt is negative du. That's not a minus, that's times the negative du. Or in other words, negative 1 over u squared du. Now, it looks like I've performed my u substitution successfully. So what I'm going to do now is recreate my endpoints. Right? I'm going to go in and say, what does 0 and pi over 6 have to change into in terms of u? So I'm going to say, what is cosine of 0? That's my lower boundary. Well, what is cosine of 0? No one. No one. Just checking in our calculators. Why not? I got these things. Page 124. Cosine 0 is 1. So we got 1. I can put that here too. And then cosine, what's my upper bound? Pi over 6.
Got it.
What is it?
I think I messed it up.
No, it's a decimal. It's an
Okay.
irrational. It's radical 3 over 2. I was like, just think pi over 6 is that 30-degree family. So if I'm looking at the x value at the 30-degree family, that's the radical 3 over 2. All right. Now, what's interesting about seeing the decimal, though, is if I just take cosine of pi over 6, it's like 0.86, right? Yeah, question.
Why do you change the end value?
Because as soon as I change it into u, I have to put the endpoints in terms of u as well. So that in the end, I don't have to plug back in t. I can just evaluate the integral with my new endpoint. Now, what's interesting to point out here is that my square root of 3 over 2 is 0.866. So there's actually two ways of thinking about this problem from here on. We could leave it as is right now. Or what we could do, because look at what I have here. I have bigger number on the bottom, smaller number on the top. Remember that rule about if you flip the endpoints, that just makes the negative, that's equal to a negative of that integral. Okay? So what I can really do is say this. Radical 3 over 2 to 1 of the positive 1 over u squared du. Okay. Flipping the endpoints of a definite integral creates the negative version of that integral. Now, did I need to do that? No. I could have just performed the integral on negative 1 over u squared and been fine. Okay. What did I actually do in my key? What did I do? I left it. I left it. Okay, I'll do the same thing that I had in my key then. Sure. I'm not going to do that then. Because honestly, it's 6 of one, half dozen of the other. You're doing the exact same thing. All right, so let's take, this is 1 radical 3 over 2. Turn that into negative u to the negative 2 du. And now to perform the integral, I take, it's a negative u to the negative 1 over negative 1. Oh, I see why I left it. Because what's going to happen to that negative? It's going to cancel. What's wrong? We good? I'm just checking my work. Yeah. No, I went back. I'm sorry, yeah. I didn't flip it because I wanted to do the same thing that's in my key. So just to show it this way. Could I have flipped it? Of course. But I'm just going to keep it the same way as I have it right now. So those negatives are going to cancel. So this is really like u to the negative 1, 1 radical 3 over 2. And now again, see at this point, once I change my endpoints, I don't need to go back in with cosine phi. I can just perform the integral process, doing the definite integral on u. So that's top minus bottom, radical 3 over 2 to the negative first, minus 1 to the negative first. Which that means that's just 2 over radical 3 minus 1. And what is that? 0.155. If you look up the answer, it probably gives you that. But honestly, I would be okay with this too. Yeah. I didn't think that was that hard. That's not too bad.
Man, I'm with you.
I don't know. It's all right. It's okay.
So yeah.
I mean, maybe. Yeah, thanks.
Can you do number 55?
55, sure. $55. Here you go. There it is. All right, here we go. Come on. Get out there. All right. So it's another one of these guys. Another one where I've got to do my u substitution and then perform a definite integral on it. What do you think my u is going to be? 1 plus 7x. Pretty easy to see there. 1 plus 7x. So that means du is 7dx. Not 70. 7 dx. And then I divide 1/7 du is dx. Okay, that means that this turns into, we've got the third root of u times 1/7 dx. Go du, sorry. And so that's just equivalent to 0, no, I haven't done my definite yet. 1/7 third root of u, du. Just putting that 1/7 out front, making it look a little nicer. Now, it looks like I've successfully performed the u substitution. I picked a good u value. I'm good. So now what I'm going to do is change my endpoints. See what my endpoints have to turn into. Well, that's 1 plus 7 times 0. My original bottom was 0. Well, that just gives me 1. Right? So there's a 1 on the bottom. And on the top, that's 1 plus 7 times 1. So that's an 8 on the top. And again, the reason I do that is so that I don't have to go back and plug in x at the end. I can just perform the integral on this stuff. So 1/7. Remember that u to the third is u to the 1/3 power, right? Or sorry, third root of u is u to the 1/3 power. So kicking it up 1, that's u to the 4/3 divided by 4/3 from 1 to 8. All right, let's see what that fraction is. 1/7 divided by 4/3. Keep, change, flip. 3/4, 3/28. You could have given me a decimal there. U to the 4/3 from 8 to 1, 1 to 8. 3/28. Yep, good. All right, so now I've got to take 3/28 times 8 to the 4/3 minus 3/28 times 1 to the 4/3. Whatever, inside, outside, doesn't matter. And let's do that. 3/28 times 8 to the 4/3. I'm going to put that in parentheses. I don't know if that's going to screw it up, but I'm going to anyway. 4/3. Right. It's 3/28 times 8 to the 4/3. I hit enter. And then, look, 1 to the 4/3 is just going to be 1. So I'm going to subtract away 3/28. Let's see what that's going to be. 1.61. 1.61. 1.607. Let's see what the fraction is. It's probably a, math fraction. There we go. 45/28. 45. But again, I would be fine with it. 1.607, 1.61, whatever you want to say. 67? You want to do 67? Just take care of all those ones at the end? Oh, yeah, this is a fun one. This is a cool one. Because it's kind of like combining one of those hard ones that we had where you got to use like the u is equal to the x plus 2 and then got to solve for x. So this is a good one to do. I like this one. Here we are. Here we go. I like this section. It's like a puzzle to me. I don't know. These problems, like once you get the right u and you make the puzzle fit, like that is fun. Sounds like you're good. All right, so u, what do we think our u is? What do you think? X minus 1. So we say du is just dx, right? It'd be 1 dx or just dx. The minus 1 goes away because we're taking the derivative. So du is dx. So that means I can take it from, well, I'll just leave it for right now. But I can't touch this x yet, right? That's not part, I just know that du is dx. So I can take this, the square, like this, square root of u du. And I still have not changed my x into u. But I know that u plus 1 is x. So now I can say u plus 1 square root of, not square root of u, square root of x squared du. Okay, let's simplify a little bit. Remember that that's u plus 1 times u to the 1/2. Which means that's going to get me u to the first times u to the 1/2, that's u to the 3/2. Right, 1 plus 1/2 is 3/2, plus u to the 1/2 du. And now I've successfully performed my u substitution, so let's go ahead and figure out my endpoints. We've got 1 minus 1 gets us 0, 2 minus 1 gets us 1. So I'm going from, instead of 1 to 2, I'm going from 0 to 1. Again, you plug in the lower boundary, the upper boundary, and that's where you put your new definite integral endpoints. All right, let's perform my integral. So that means I've got u to the, pick it up one, u to the 5/2 over 5/2 plus u to the 3/2 over 3/2 from 0 to 1. Let's just simplify that a little bit. Keep change flip. That's 2/5 u to the 5/2 plus 2/3 u to the 3/2 from 0 to 1. Well, the nice thing about this one is I've got some nice numbers here. 2/5 times 1 is 2/5 plus 2/3 times 1 is 2/3 minus, life is good when I got a 0 down there and I'm working with a polynomial. Yeah. So 2/5 and 2/3. Okay, that's, I can do this without a calculator. What would that be? No decimals. Let's just do it with fractions. Come on now. We've got 6/15 plus 10/15. That's 16/15. 16/15.
I got
Nice job. Proud of you. 16/15, which is, in other words, 1.06. Repeating. Full disclosure, I had 1.06 in repeating. I didn't actually do it. 16/15. Yes, sir.
This isn't for the problem, but we have, like, something, when we get, like, weird fractions and we have to do, like, the power rule.
Yeah.
Do you want us to, like, go through and simplify that as much as it is, or can we just keep it, like,
Keep it live.
I don't know, like, on 24? I don't know.
Let me take a look. What I would like you to do, didn't we do 24?
Yeah.
Yeah, I would like you
So at least just flip the bottom.
to at least just flip the bottom and then perform any operation you would have to do on this. Do you have to do anything with like bringing that stuff in? No, don't touch that. That's fine. But at least perform the operation on the front. Amanda? Sure, I'll try. Why not? The problem doesn't look that lengthy. They're always good when they're like a different color. That's always a good problem. Some good stuff there. All right, so, ooh, this one looks tricky. It looks like the only thing that's within something else is the ln of x, right? So it looks like u is ln of x. So du is, well, what's the derivative of ln of x? 1 over x. 1 over x dx. Now, that means that this can turn into 1 over x times the square root, really, it's kind of like ln to the negative 1/2 power, right? dx. Because it's in the denominator and it's a square root, so it's like negative 1/2 power. So this is where I'm seeing the 1 over x dx. That's du. Okay. So this gives me ln of u. No. It's u to the negative 1/2 power. du, is that it? Oh, that's kind of convenient. That's nice. Because u is ln. So now I find my endpoints. I say, okay, ln of x is my u value, so ln of e, the bottom, well, ln of e is just 1. So I got 1 on the bottom, and then I find ln of e to the 4th, and that's just 4. So that means I've got from 1 to 4. All right, perform the integral. That's kick it up 1, u to the positive 1/2 power over 1/2. And that's it, right? From 1 to 4. So that means it's 2 u to the 1/2 from 1 to 4. Or in other words, 2 times the square root of u from 1 to 4. So 2 square root of 4. Oh, this problem's good. This is a good one. Minus 2 square root of 1. So it's 4 minus 2 is 2. Right? Yeah. That one's cool. The ones that are colored different are cool. You don't know how to do 30? That one got, number 30, maybe I can give you some pointers. Make u tangent x. And then du is going to be secant squared x. That's just a tricky trait. Really negative tangent x to the negative 1. Measure u? Yeah. See, that's another one, but because you could have taken either secant or tangent as your u.
Well, because I Googled like the antiderivative of cotangent square one and it gave me negative x
Oh, I see.
minus cotangent x. So where does that negative x come
But if you take u as just tangent x, that'll get you to the right place. All right, so long, everybody, playing along at home.
Bye.
See ya.